So today I'd like to explain what is a common base configuration. So it actually looks more formidable than it is. In fact, it might be even easier than the voltage divider bias configuration. So it's all the same transistor, but just from a different perspective. The emitter, collector, and base all remain the same. So if we start off from finding what is our current that flows through the emitter is equal to, let's first consider the mesh current equation. So here we will have our VBE. And if we take the mesh current equation in this direction, in the anti-clockwise direction, we will have VEE with a minus plus RE IE plus VBE equal to 0. And our IE in this case is equal to VEE minus VBE over RE. Okay? So if we want to see what is our VCE is equal to, then we can take a mesh current equation of this whole thing anti-clockwise again. You can take clockwise, but it just only affects the signs. It will never affect the final value unless you made some mistake with the sign. So RE IE minus VEE minus VCC plus RCIC plus VCE is equal to 0. So our VCE is equal to VEE plus VCC minus IC RC plus RE. Okay? We might as well be interested in finding what is our VCB is equal to, and all the same, just like this equation, minus VCC plus IC RC plus VCB is equal to 0. So VCB is equal to minus IC RC plus VCC. And that's all with the formulas. It's quite straightforward compared to what we've had previously. So now we can move on and solve a problem on this configuration. In this case, we have to find IE, IB, and IC, VCE, and VCB. Okay? So our IE, if we just put the values into this formula, will be equal to 4 minus 0.7 over 1.2 multiplied by 10 to the power 3. This will give us 275 multiplied by 10 to the power of minus 3 amperes. So this is basically 275 milliamperes. So our IB will be equal to IE over B plus 1, and IC will be equal to IB multiplied by beta. So this one I will leave to you, but IB will be equal to 4.58 10 to the power minus 5 amperes. VCE will be equal to 4.1 volt, and VCB will be equal to VCC minus IC RC, which is 10 minus 2.4 multiplied by IC, and you have to get minus 3.4 volts. So just check if you got the same. And I hope you find this video helpful.